Let me introduce our work with the title RGB Images-Driven Recognition of Grapevine Varieties. As the title suggests, our work is closely related to agriculture mechanization. The current trend in agriculture mechanization is clearly towards full automation of the mechanization. This process is supported by availability of precise manipulators, sensors, powerful processors, and advanced data processing techniques. We contribute to this process by our research in the area of automatic selective harvesters. Herein, we present our research on intelligent sensors for selective grapevine harvesters. Our primary requirement on an ideal intelligent sensor is accurate recognition of grapevine varieties, where the process must be fully automatic. The second requirement is low price of the sensor. As feasibility analysis shows, recognition of varieties is a classification task. It can be carried out visually or using a wet chemistry technique. As wet chemistry techniques are destructive and time-consuming, while the visual ones are not, we consider visual techniques to be more appropriate for their utilization in agriculture mechanization. 100 years of experience show that experts can accurately recognize tens of varieties just based on their vision. Another important fact is that conventional color cameras are the cheapest sensing devices suitable for this task. Moreover, modern data processing techniques such as deep convolution networks achieve human-like classification accuracy on RGB images. Considering all these facts, we conclude that a conventional color camera in combination with a deep convolution-based image categorization system can result in the ideal intelligent sensor for selective grapevine harvesters. In order to develop this sensor, we have to design an accurate image categorization system. As deep convolution-based systems must be trained and evaluated prior to their utilization, we have to form an appropriate dataset of labeled images as first. Datasets must be formed with respect to given tasks. Considering this fact, we included in our dataset 3 varieties with green grapes and 4 varieties with red grapes. Further, we extended the dataset about images of background. Such a way, we form a dataset of 7,200 images which were classified into 8 categories, where each category contains 900 images. The images are cutouts of RGB photos of common grapes captured during a harvest. The photos were captured at various locations without any artificial lighting, in a direction of sunshine, likewise in the opposite direction. We implemented the system as a deep connect with a dense connectivity pattern. The network ensures both feature extraction and classification of raw images. We trained the system on a class-balanced subset of the dataset. We used data augmentation techniques to bring more variability into the training dataset. We evaluated the system on the complement of the training set. The evaluation set consists of 150 images of each class. We summarized the evaluation results into a confusion matrix. As results show, the system correctly classifies almost all images. The best recognized variety is gewürztraminer. The worst recognized varieties are St. Laurent and Welsh Riesling. St. Laurent was mostly misclassified as Pinot Noir. Both varieties have red grapes. Welsh Riesling was confused with other green grape varieties. It was mostly misclassified as Veltliner green. As expected, the system well distinguished between red and green grapes varieties. It also well distinguished grapes from background. The overall average accuracy of the system is above 98%. The results confirm our hypothesis that in-field color images of ripe grapes acquired by a conventional camera can be used for classification of grapevines according to their varieties. The presented system is capable to distinguish among 7 grapevine varieties with very high accuracy. It is capable to work without artificial lighting, even on images captured in direction opposite to sunshine. We conclude that the proposed solution allows construction of affordable automatic selective harvesters.